So these are very common notion, as we already know. Software is a compilation of interconnected objects or a set of instructions to perform any task. So we might have different components to develop an software. So one could be responsible for maybe your system login, one could be front end, one could be back end. So these are systems. So software has different components, and these components actually are built with objects, and these objects can exchange information from one component to other component. We know that objects are actually formed from the classes. Class is, that it's a blueprint of what we would like to perform. So it's a kind of system. System usually a functional, maybe ecosystem. It's a functional product where we have a kind of components. They are interconnected with each other, and they can exchange information. So this is our software system, kind of software system. What we actually do in a say in acceptance testing. So for acceptance testing, you can see that framework component. Framework component is the basic building block of any system. So to access the system, we might have different external interface, maybe say API or any other interface through which they can connect. So this is web service component. And for this functional component, we may have database component to store the data. And tested component means which part we want to test for, maybe for validation or say quality assurance or quality control. And so this part will likely to have a more focus in the later part of our course. And GUI overlay is a kind of a graphical interface, or it's just component array through which user will connect. So in acceptance testings, we'll perform likely the it's if you say the acceptance testing, it's from the customer side. And for say validation or quality control, it's a kind of your from the management side or developer side. They will check whether we are following the standardized techniques developing thing. So these are very common idea we know already. So software life cycle. So if we find that the upper 6 part, so these are our software process, and the below we can see is the software maintenance, and when the software actually become obsolete, or it actually go to the terminated state or end of the support. So upper 6 modules are our software process life cycle. So we know that in the requirement analysis, whenever who are the actually target customers, what is the purpose of the system, so it will be developed in the requirement analysis. So after analyzing the requirement, we will make some specifications. Specifications in the form of maybe it's a functional requirement, maybe non-functional requirements, or different stories, use cases. So there are some specification which can be easily converted into a design form. So in the design state, we actually develop the main architecture of the system. And in development step, we will any source code or maybe any of the programming language to convert the design into a functioning software. So quality control and quality assurance. So these two part actually, one is in the terms of the management process, and another one is in terms of the developer's process. So developer process, what do they do? They usually do the unit testing thing, regression testing, prioritization testing, these are things. Finally, when it is developed, we just submit to the customers. So this is called actually or acceptance testing. There will have some use cases. They just check whether it is pass or fail. Finally, our main focus is the software maintenance. Actually, software maintenance is a post delivery activity. Why study software maintenance? Because maintenance consume a major part of our financial resources of any software development. So during operation software, maybe we find different detect that the problems may be detected that were not detected during the validation and acceptance test. So during development, maybe during unit test, we did not find it. But when we are submitting to a customer or we are finding some error, so that time definitely we need the maintenance work. So software maintenance is commonly needed when upgrading the system components, especially database or operating systems. When you need to improve, you need to perform the software maintenance thing. Software maintenance it covers a significant portion of the life cycle cost. Software maintenance uses a number of tools, methods, and techniques. Maintenance is required on all types of software, whatever our technology, techniques, or tool use to create it. I'm just reading this thing. So here we can see that there was a rule of thumb. If we need to pay €1, we will come up with a proof of concept or prototype. It costs €10 for test and develop the product, but €100 for the maintenance thing. And we largely ignore this thing. So definitely it's a very important task of the entire life cycle. It is actually a software maintenance process. So in the process implementation, we can set up what are the things we are going to test or maintain things. So this is process implementation. That means we can develop the test use cases. So later we need to identify the problem and the modification analysis. So from the steps to actually start our software maintenance task. Here we implement our changes, and if any modification we need, then we can do that thing. Sorry, in the second step, we just analyze the thing. And the third step, we just develop or implement the our analysis that we need, that what we need to actually modify this thing. And finally, we check whether our modification is okay from the customer side. And that's why we are telling that the acceptance test for the software modification. If we have some other problem, then it will just circulate. So in terms of time, we may need to migrate the system, for example, our operating system or maybe any other working environment that time. So we need to migrate. But over the time, our software life cycle might be end, and this is our retirement thing. So these are different types of software maintenance. First one is corrective maintenance. Corrective maintenance means if you find any bug or if is there any deficiency. So this type of maintenance is called corrective maintenance. If you find any faults, this could be a functional requirement. So you know what's the difference between functional and non-functional requirement? You have any idea? Can any of you share?
The functional requirements describe features, what the product can do, and whereas non-functional requirements describe how it does, what it does, what kind of characteristics it has, I would say.
Okay. Actually, yeah, to functioning the product or system, functional requirements are essential. But if we need improve our satisfaction to use those products, those are non-functional requirement. For example, maybe how easy to use a product. So it is kind of your non-functional requirement, or how safe the system is. This is kind of non-functional, but maybe the system login, this is definitely one functional requirement. So in course of time, the safety thing also became one functional nowadays, but it's difficult to measure how we say that the safety things are assured or confirmed. So this cannot be actually guaranteed. So these are kind of non-functional. So in our corrective measurement, we will check when these modifications of the required code is satisfy functional requirements. So corrective measurement, when after deploying a system, it is not working nicely, efficiently, or it's not operating well. So in those cases, we need corrective measurement. So adaptive maintenance means if we change the environment of if we need the data. So these are called adaptive maintenance. To cope up in a new system, what are the maintenance technique we will use? This is called actually adaptive maintenance. So one is called perfective maintenance. Perfective maintenance means, for example, I need to enhance my system after delivering it. Without this feature, I cannot serve my customers well. So these are called your perfective measurement. So if we want to make, after delivery, if we feel that there is some lacking of the software, so I need to make it complete for managing all of my tasks. So this is kind of your perfective maintenance. The modification of software product after delivery, implementation new or change user requirement. This is called perfective maintenance. So preventive maintenance means it is a kind of one proactive approach. So there might be some latent or hidden errors that I need to deal with. So if I can fix it in advance, so this maintenance is called preventive maintenance. So if we can see, these are actually based on very old data, though I can maybe show you the latest. So types of maintenance based on it's just statistics. What types of maintenance have been performed to how extent, what extent. So corrective measurement is almost 21%. preventive is very low. We are kind of reluctant to use the preventive measurement. Adaptive 25%. That means so perfective maintenance 50%. So it says that we actually like to enhance our features or product after delivery a lot. And after that, usually the cost raises for this thing. And that's why 93% of the cases, actually our majority of the cost actually belong to the software maintenance things. So types of software maintenance and program aging. So in the introductory stage, we usually give the support to the customers. But once it is deployed or in the operational stage, so there are some faults. We need to fix those bugs. When it is already in the mature level, so we try to incorporate some other features. And in terms of time, in course of period, actually it become obsolete. So we just decline. So these are the most typical maintenance problems: say unstructured code, insufficient domain knowledge, insufficient documentations. These are the basic. So tools we'll use later. So these are the indicators that system need maintenance actually. So if a system frequently make errors or fail, then definitely it's an indication that we need maintenance. So overly complex structure, actually, if our system has a different structure, overlay means over the time, different part of the system has implemented many things. For example, a class raises very large in course of period. There are some classes, majority of the cases, we implement most of the thing in a single class. Sometimes it happens that one function is accessible by many other functions. And this is called, say, NV function, or like this type called NV function. This is called. Or sometimes we see that some part of the code actually are not used, but still there. So if our system actually become very complex to understand, because many developers has come in course of time, they have changed a little, they may be gone somewhere without any commenting or documentation thing. So one system could be complex in course of time. Running in emulation mode. Simulation mode means there are some system this is not real, but we mimic, we pretend that this is a real system. So in some software, it becomes that we run in the emulation mode. Emulation mode, for example, I have a software, they use my DOS, but definitely nowadays DOS system is not available. So what can we do? We can use one DOS box, there is one emulator, and deploy my product there. Even I need maybe one Windows XP system, but I do not have that system. But my software actually recognizes that system. So what I will do, I will use virtual machine, and in the virtual machine, I can run my software. So these are kind of so this is a very good indicator that the system might become obsolete. We might need to perform maintenance. So very large component, I have already covered a little part in the overly complex structure. So very complex, a very large component is if our one function, one class become very large course of time. So that means it is very large component. If my system need a lot of RAM or maybe virtual memory or secondary memory. So if these are required, so I need to reconsider whether I need to efficient resource uses for this. Should I need to check the data structure or how the system is consuming these resources? And if we have lack of documentations and high personal turnover, as I told before, that if I have a lot of developers are coming to the organization in the same project, many persons are coming, they are developing maybe a few classes, a few components without writing the documentation well, or maybe they are very new, they are very intern developer, they have randomly wrote something without following the standard techniques. So this could be one good indicator. And different technologies we use in the same place. So this is one indicator that and to consider that system has been decayed, we might need to maintain it. So in summary, so main problem is the unstructured code, insufficient domain knowledge. So yes, insufficient domain knowledge could be, for example, I need to develop an accounting software or financial software, but developers have no domain knowledge, or maybe on medical software, I do not have maybe that much clinical or psychological or any knowledge, this knowledge. So it's difficult to build. So it's very usual that there might be some error and it will have some issue. So layman's third law is a system that is used will change. Yes, this is true because technology is changing nowadays. If you find, for example, now people are using generating AI, right? Generative AI. That means maybe ChatGPT or related to say Gemini. There are similar other many technologies. So it will be, I think, maybe after a few years, it will be also obsolete. So what we are using, especially the technologies, it never always, it never actually remain latest technology. Sometimes it will terminate, it will change, it will end its actually era. So this is all about today's introduction. So if you want, I can show you the technical reports, the projects that are really, maybe I can give you some ideas, or I can just share. Did you attend, did you use definitely ChatGPT have you used, right? Did you use the API of it? Okay. Actually, there are two types of large language models. One is called open access and another proprietary. So proprietary, you know, that category could be used by paying money. For example, ChatGPT. Maybe you can use freely, but you have some limited number of tokens to use. So most of the giant companies were actually developing their generative model. So those will be, you have to pay actually. So sometimes somehow you have to pay. But if we have also some other open access large language model. So I would request you to check those models. For example, it has a number of parameters. So part2 is one Python, there is course Claude, Minstrel, and there are some other GPT Neo. These are actually different open access elements. So for your project, you can access to Hugging Face. Did you access ever Hugging Face? So you can access to Hugging Face, and it has a different transformer-based platforms and APIs. You can enroll there, or you can register there by using their tokens, by using their identifications or token IDs. You can use those platforms, and so you should plug and play those things. Otherwise, you cannot apply this thing. Though it's not directly connected, but nowadays people, even in the industry, they're using this generic AI. There's another instruction for your learning. Definitely, you are welcome to use ChatGPT, but for project writing, please do not. I would request you not to use the ChatGPT directly. You can learn from there, but you can use. So I'm just uploading it, and do you have any question, anyone in the online event? Any query? Yeah, can retake, because maybe in the summer, and then maybe you can attend total 3 exam, I think. So far, I know. End of this semester, there are 2 other.